A barren landscape under an alien sky.
Red dust blows across a silent plain, where rocks and sand dunes stretch as far as the eye can see. But something amazing lies beneath that dusty surface, something that has led scientists across the globe to gasp in excitement.
Could this landscape, so desolate and foreign, actually hold the secrets to life itself?
The question that has haunted humanity for centuries, are we alone?
Might finally have an answer hidden in a single rock on Mars.
Recently, the NASA Perseverance rover stumbled upon something remarkable.
This wasn't just a typical rock sample, another chunk of Martian terrain. This rock was different, boasting strange leopard-like spots with dark rings of iron and phosphorus, substances that could signal the presence of microbial life. On Earth, these patterns are often created by microorganisms interacting with minerals. But could this same phenomenon exist on Mars?
And if so, what does that mean for our search for extraterrestrial life?
Let's dig deeper into what makes this Martian rock so fascinating. Named Chava Falls by the scientists who discovered it, the rock measures about 1 meter long and 60 centimeters wide, and its surface is dotted with unusual shapes and patterns. These leopard spots are embedded in hematite, a type of iron oxide commonly found on Mars.
But what truly sets Chava Falls apart is the composition of these spots and the darker material surrounding them.
According to scientists, the dark rings around these spots contain iron and phosphorus, compounds that on Earth are often linked to microbial life. The very appearance of this rock, with its irregular shapes and chemical composition, is unlike anything researchers have seen on Mars before. In fact, it's one of the most significant potential signs of ancient life that Perseverance has uncovered in its mission so far. So, let's entertain a tantalizing question: what if these spots are evidence of past microbial life on Mars? On Earth, microorganisms known as extremophiles thrive in some of the most inhospitable places imaginable, places with extreme heat, intense cold, or even high radiation levels. It's possible that similar life forms might have existed on Mars billions of years ago, back when the planet was a wetter, more hospitable world. Scientists speculate that these microorganisms, if they existed, could have utilized the iron and phosphorus found in the rock as part of their energy processes. Just as certain Earth microbes use minerals to survive, Martian microbes might have adapted to use these resources in the ancient lakes and rivers that once flowed on the planet.
And here's the kicker: Chava Falls was found in Jezero Crater, a location that scientists believe once held a lake.
This means that the rock's location adds weight to the idea that life could have flourished there when Mars was more habitable.
But why Jezero Crater?
Why did scientists choose this location for the Perseverance rover's mission?
The answer lies in Mars' ancient history.
Billions of years ago, Jezero Crater wasn't the dry, empty basin we see today. Instead, it was a sprawling lake, filled with flowing water and fed by rivers.
This environment would have been rich in nutrients, creating ideal conditions for life.
The shape and features of Jezero Crater strongly suggest that it was once home to a vast body of water. River deltas can still be seen etched into its landscape, evidence of the ancient water flow that shaped the region.
Scientists have long believed that where there was water, there could have been life. And that's why Jezero Crater is so significant.
This is where the Perseverance rover has been diligently searching for signs of ancient Martian life. As exciting as these discoveries are, confirming life on Mars is no easy task. Even with the Perseverance rover's advanced instruments, there are limitations to what can be analyzed remotely. The rover uses tools like lasers, spectrometers, and cameras to study rocks from a distance, but these instruments can only go so far in identifying organic compounds. To get definitive answers, scientists will need to bring these Martian samples back to Earth, where they can be analyzed in state-of-the-art laboratories.
This ambitious plan, known as the Mars Sample Return Mission, is still in development, but it holds the potential to unlock Mars' deepest secrets. The challenge, however, is not just about transporting rocks across millions of kilometers of space.
Scientists will also need to be cautious in handling the samples to avoid contamination from Earth's own microbes. Every step of this process must be meticulously planned to ensure that any signs of life found in these rocks are truly Martian.
One of the biggest mysteries about Mars is what happened to its water.
For years, scientists assumed that much of Mars' water evaporated into space after the planet's magnetic field weakened, leaving it vulnerable to solar winds. Without a magnetic field, Mars couldn't retain a thick atmosphere, and its water gradually dissipated. However, recent research suggests that not all of Mars' water was lost to space.
Instead, it might have seeped into the ground, forming massive reservoirs beneath the surface.
In fact, recent seismic data from Mars InSight suggests that the planet's crust contains significant amounts of water trapped in rock layers.
If Mars still holds vast underground water reserves, this raises exciting possibilities.
Could life be hiding beneath the Martian surface, protected from harsh surface conditions by layers of rock? This underground water could provide a refuge for microbes, potentially allowing them to survive in isolated environments, much like the deep-sea life forms. Let's imagine, for a moment, what might lie within Mars' underground reservoirs. On Earth, we found bacteria and other microorganisms thriving in environments previously thought to be uninhabitable. Could something similar be happening on Mars? If liquid water exists beneath Mars' surface, it could be an ideal habitat for microbial life. These subsurface environments would offer protection from radiation and temperature extremes, creating a stable environment where life could potentially exist. In this way, Mars' underground water reserves could serve as a hidden world, sheltering life from the planet's harsh surface conditions.
This concept isn't just hypothetical. Researchers have discovered underground lakes in Antarctica and other extreme environments on Earth where microbes thrive.
These discoveries inspire hope that similar life forms could exist on Mars,